Assalamu alaikum dear students, this is our next problem having been chosen from the same book Modern Physics by Stephen T. Thornton and Andrew Rex. As usual, we first come to its statement. Okay, a spaceship moves radially away from Earth. Dear students, we know that Doppler effect has two classifications. In one case, object is approaching, in other case object is receding, going away. Okay, a spaceship moves radially away from Earth with acceleration 29.4 meter per second square, that is to say about 3g. Here g does not stand for gram, g stands for acceleration due to gravity, which is 9.8 meter per second. Okay, how much time does it take for the sodium street lamp, lambda equal to 589 nanometer, nano standing for 10 to power minus 9, street lamps lambda equal to 589 nanometer on Earth to be visible with a powerful telescope? To the human eye of the astronauts, the range of visible wavelengths is about 400 to 700 nanometer, nano standing for 10 to power minus 9. Okay, dear students, here two wavelengths we have to choose. One wavelength is this, lambda equal to 589 nanometer, and second wavelength we will choose this 700 because it is at extreme position. Okay, it is given that the range of visible wavelengths is about 400 to 700 nanometers. So the boundary value, that is last length, that is 700 nanometer, we will take this. Okay, one of these will be denoted by lambda and other by lambda naught. Okay, now we move to solution and one by one things will become clear. Okay, dear students, solution. In solution portion, first of all we go through some information about spectrum of electromagnetic radiations. Okay, because here wavelengths of light are involved. Okay, 589 is one and 400 to 700 nanometer is other. Okay, so first we go through these two snapshots which are about spectrum of electromagnetic radiations, electromagnetic waves. Okay, table: violet, blue, green, yellow, orange, red. Okay, violet is from 380 to 450 nanometer and similarly red is from 620 to 750 nanometer. Second snapshot is the alternate version of first. Okay, here again from violet to red. However, in red it is described that wavelength of red is from 625 to 700. Okay, in first snapshot boundary line is 750 while in second is 700. Okay, so second is relatively more closer to our statement because in our statement it is described that 400 to 700. Okay, so this is 400 to 700. Oh, anyhow, both these snapshots are 100% correct. However, second snapshot is relatively more closer to our statement. Okay, now we come towards the Doppler effect. Okay, Doppler effect, electromagnetic wave, the source approaching observer. Okay, frequency measured by observer f is equal to c plus u over c minus u under root into f naught, where f naught is the frequency measured in rest frame of source. U is the speed of source relative to observer, while c is the speed of light in vacuum. Okay. Yes, students, Doppler effect is once again given in the next snapshot, in which it has been classified in two parts. Okay, one is approaching case and the other is receding case. Okay, Doppler effect. Source or observer approaching, in this case f is equal to 1 plus beta over 1 minus beta under root into f naught. Source or observer receding, in this case f is equal to 1 minus beta over 1 plus beta under root into f naught, where beta is the speed parameter v over c. Okay. Next snapshot is again alternate versions. Okay, of Doppler effect. Approaching f equal to 1 minus beta square under root over 1 minus beta into f naught. This alternatively becomes equal to 1 plus beta over 1 minus beta whole under root into f naught. Okay, this is approaching case. Second is f is equal to 1 minus beta square under root over 1 plus beta into f naught. This alternatively becomes equal to 1 minus beta over 1 plus beta into f naught receding. Okay, our case is receding. Our statement falls under the category of receding, because in this statement it is said that a spaceship moves radially away from Earth. Okay, so away from Earth means receding. So second will apply. Okay. In the next snapshot, we are giving some introduction about speed parameter. Okay, if the relative speed between frame is v, the contracted length L and the proper length L naught are related by L equal to L naught 1 minus beta square under root is equal to L naught over gamma, where beta equal to v over c is the speed parameter and gamma equal to 1 over 1 minus beta square under root is the Lorentz factor. Next, Newton's laws. Okay, in rotational and translation, these are distinguished. Okay, from here we will choose this Vf equal to V naught plus AT. Okay, now we move to our solution in a proper manner. Okay, using f over f naught equal to 1 minus beta over 1 plus beta, 1 minus beta under root over 1 plus beta under root. We can combine these in a way that whole under root 1 minus beta over 1 plus beta, it does not make any difference. Anyhow, dear students, we know that frequency and wavelength are reciprocal of each other. F is equal to c over lambda. So in place of frequency f and f naught, we are using c over lambda and c over lambda naught. Okay. In the next step, lambda naught will be shifted to upper part of the numerator. Okay, because a numerator contains upper and lower portion and denominator also contains upper and lower portion. So lower portion, the denominator, will be shifted to upper part of the numerator, and hence we will get lambda naught over lambda, because c will be cancelled with c, and hence lambda naught over lambda will become equal to this 1 minus beta under root over 1 plus beta under root. In the next step, we are going to take reciprocal of each other. In the next step, we are taking reciprocal of each other by taking reciprocal of both sides. Both sides are inverted and we get lambda over lambda naught is equal to 1 plus beta under root over 1 minus beta under root. Okay. Okay, this. In the next step, we are taking square of both sides. In this way, both under roots in the numerator and denominator on right hand side will disappear, will vanish. Okay, and hence lambda over lambda naught square will become equal to 1 plus beta over 1 minus beta. Here we are going to put those two values which have been provided in the statement. One is 589 nanometer, while second we have chosen by our own discretion as 700 nanometer, because it is described that visible range is from 400 to 700 nanometer. So we are taking the last boundary boundary nature value, that is 700 nanometer. Okay, hence now we have put these two values in place of lambda and lambda naught, and here 700 when divided by 589, and then its square will be equal to 1.41. okay, here two steps have been merged in one step. Okay, in one step it could be shown the result of 700 over 589, and in the next step we could take square of that, but here we have merged two step, and hence 700 divided by 589, resultant value squared becomes equal to 1.41. This is equal to 1 plus beta. Okay, here 1 minus beta will be multiplied by this factor, and we will get 1 minus 1.41 minus 1.41 beta minus 1. This figure, this factor will be shifted on other side of equality, and hence these both values will become minus. Okay, so 1.41 minus 1.41 beta minus 1 minus beta equal to 0. Here, dear students, when 1 is subtracted from 1.41, it will become 0.41, while here both signs are negative, so these two will be added, and hence we will get minus 2.41 beta. Okay, because this is 1 beta and this is 1.41 beta, and both have minus signs, so both will be added, but their sign will still remain as minus. Okay, so it will become 2.41 beta. By transferring it on other side of equality, 0.41 will become equal to 2.41 beta, and hence beta will become equal to 0.41 divided by 2.41, and hence beta will become equal to 0.17. Okay, this is the value of beta. What is beta? Beta is speed parameter, that is V over C. Okay, now beta is equal to 0.17. We know that beta is speed parameter V over C, that is from here V will become equal to 0.1 into C, and we know that value of C, that is speed of light, is 3.0 into 10 raised to the power 8 meter per second, or 2.998 into 10 raised to the power 8 meter per second. Okay, after simplification we will get the value of V as V becomes equal to 0.51 into 10 raised to the power 8 meter per second. Dear students, in the next step acceleration is given. We are using this expression of Newtonian mechanics. Okay, Vf minus Vi equal to Vf minus Vi is equal to At. Okay, that is delta V over T is equal to A value of A is given in the statement as 29.44 meter per second square. Okay, this is approximately 3g. G is acceleration due to gravity, that is 9.8 meter per second square. Okay, so when we multiply 9.8 meter per second square with 3, it becomes approximately equal to, or perhaps exactly equal to 29.4 meter per second square. Okay, and the value which we have find V, we have taken that value as delta V, change in velocity. Okay, or we can say that we have taken that value as final velocity Vf, while Vi is assumed to be 0. Okay, anyhow, In place of acceleration, this value which is provided in statement is put, and here the velocity of v which we have found in the previous step is put, and here time is still as it is. It is not disturbed yet because we have to find out this value t. Okay, this implies that t will become equal to, t will be shifted on other side of equality and it will become in the numerator, while this value of acceleration, that is 29.4 meter per second square, will be shifted on the other side of equality and it will become in the denominator on the other side. Okay, next this second square which is in the lower part of the denominator will be shifted to upper part of the numerator, and hence second will appear in the numerator while meter will be cancelled with meter, and after simplification we will get 0.017349 into 10 raised to the power 8 second. If we convert it into 10 raised to the power now we have removed this decimal, and by multiplying it with 10 raised to the power 8, it will become 1.73469 second. Okay, simply we have multiplied it with 1 into 8 zeros, and hence we have got this value. Okay, this is second, but actually we have to find the time of spaceship which is definitely in days or months. Okay, longer period. So we are going to convert these seconds in hours, and then in days, and then if necessary in months, but to the extent of days it will be sufficient. Okay, 1734690 divided by, first we have divided it by 3600, that is 60 into 60, it will become hours. Now we are dividing it by 24, so it means we are converting it in days. Okay, when we divide these seconds by this number, it is converted into days. Okay, and this is equivalent to, this is equal to 20.08 days. Okay, so time t has become equal to 20.08 days, which we have to find out, and this is the end of our problem. This is the end of our video. Till next video, Allah Hafiz.